So, my name is Rory Hope, and this is my colleague, Rory Sinha, who has, in fact, the correct Twitter handle, we're here to wrap up the Rory track. We come from a company called Cigital, which you've seen. We sponsor the conference. I absolutely love coming out here every year. And we've hired a couple of grads from here before. We do software security. So, yeah, we do some of the pen testing stuff. We also do security requirements and architecture analysis and design review and source code analysis and security testing, which is slightly different from penetration testing per se. So we do all that sort of thing. We're consultants. We've got a few dozen of us in London and 200 and some in the US. So what I want to talk to you today about is the art and science of security testing. So we got black box, we got white box. What does that mean? What's it all about? So what we're going to do, if anybody asks you what you did today, you were looking at two different kinds of testing, comparing the advantages and the disadvantages. You were not playing with roller coasters. All right, that's the whole goal here. Instead of giving you software to break and software to figure out what's wrong with it, we're going to use this as our software. So the source code, yeah, that's the track. The box, this is a production environment. Remember, developers don't go into the production environment, right? So we have got the code inside the production environment. And what we're going to do is we have bugs in our software. We need to find them. We need to figure out what to do about them. And then we actually need to fix them. This is what happens in the real world, right? We have software. It has bugs. We have to find the bugs. We have to fix the bugs. So we're just going to do the same thing. We're going to do it on roller coasters. Quick orientation, I want to sort of define the terms here. What is black box testing? Black box testing is when you treat the system as a black box. You don't know what happens inside, you don't know how it works inside. You can give it some inputs, you can interrogate the outputs. But what on earth happens inside this box, we don't know. So a lot of times you'll have access to a running system, maybe it's in a production environment, oh God help you, or it's in UAT, or some other kind of test environment. You might get login credentials, so that you can get a little bit deeper into the app. Sometimes they say, you know nothing. What can you do? You might get access to some of the output logs. You might not. And you might get documentation, but it's probably like the same kind of thing they give any end user here. This is how our system works. Now, some people might say, well, gee whiz, if you've got login credentials, that's a white box test. And that, for our purposes today, is not what I mean. For our purposes today, the white box test is when you can see the source code. Right? If you can pick up the phone and dial up the lead developer and say, hey man, looks like this thing is actually processing the XML directly and not sending it to a parsing library, is that right? Then you're doing white box test. You can see what's inside the box, you totally know how it's built, and you can really understand the actual business logic. Now, with that, you might also be able to see the config for the runtime. You might have shell access to the host. You can look at the server.xml file. You can see how this thing is put together on the inside. You might have the ability to compile the code. Every once in a while I get that. You might even get the ability to run the code you compiled. So you can say, what happens if I did this and this? And then run the code that you've changed. Less and less often can I do that. And you might be able to actually interact with the software that you have compiled. You can actually stand it up in the test environment and run. But that's what I'm talking about when I say white box. Complete and total utter access to everything inside the box. So if you're wondering what this is supposed to look like, this is the system that we're testing. Oh, sorry. This is what we showed the investors. So this is what the investors invested $4.5 million in. That's not actually what you're going to be working on today. What we're actually delivering in the first iteration, more like this. So technically it's 1/64th scale. It doesn't actually have humans riding a car. Not quite the same target demographic. But it's version 1. The investors, they're really pleased with it, and they're sure we're going to get second round funding.
Right, so to get this started, we need 2 teams. So I'm going to pick 5 people from the left side of the room. So we'll split this row down the middle, and 5 people
So
want
if
to
you're to
play
the
around
left
with
of
it.
me,
Yeah.
5 volunteers. Raise your hand if you want to come down and be part of our testing team.
You get to play with roller coasters, otherwise you just get to kind of,
Okay, we got some guys in the back. Come on down, guys. It's 5. Yeah, I need 5 over here. I'm gonna need 5 over here. You guys aren't going to the bar until this gets done, so you might as well stand up and get this done. And if you're in a blue shirt, you're perfectly eligible, but you know what? Anybody, come on, give me 5 over here. 1, 2, 3, 4. All right, let's make it 6. Come on, you don't have to stop. They've got an advantage on you.
oh, so, can you, right, when I said you can play with roller coasters, I might have lied. Your job just now is to look at this box and tell me why is the roller coaster not working. And this is the view that you have. And the rules are on the board. You can use the car. You can kind of
You can hit the switch.
Yeah, you can hit the switch, move it around a little bit, and you can't open the box and you can't try and do sly hacker-like things to it. Just not. So that's all you get to do. You get to switch on the roller coaster and see how it works. And basically, you try and figure out what's broken.
And the switch goes in 2 directions. I highly recommend pushing it away from you, which will bring the car up.
Yeah.
You don't get much data when you push it the other way.
Yeah, it's,
Right.
it's a design.
Is anybody, are you going to be able to write anything down? No, you're going to have to remember them. Because what you're going to have to do, right, is you're going to have to tell us what you think is wrong and what evidence you have for that. It's a black box pen test, man. I expect some output.
Yeah.
All right, so somebody from each team, push the switch. Let's see what happens. There's the car. Let's see the output.
Right. That's it works quite well actually.
It's a car timeout exception. That is in fact correct. It does not appear to be working.
Yep.
Me still compiling.
Is it still compiling? Yes, all right.
Right. So based on what you've seen so far, you should try and remember what you think is broken. Anyway, so previously we did have some people look at our roller coaster and tell us why it wasn't working. They gave us this really nice report with a very interesting font as well. So, so the report is something like this: the roller coaster does not seem to be functional. Yeah, actually, that was a very, very sharp observation. Causes include a low coefficient of friction in the flat full. Now, English is not my first language, and Old Norse really not my language at all, which make the gruntal slip over the dag stop, and the omyuks not fitting together tightly, which obviously, it was kind of obvious if you think about it. And improper fricantic repairs, often in low temperature environments. That's where
We're saying it was chilling here this morning.
Yeah, yeah. And the underlying issue, however, which is something that I'm really interested in, because I want to fix this. The underlying issue is obviously, is often, well not obviously, it's often a load miscalculation. So, from this report, I see words, and I see that some of these words are probably important, but I have no idea what they mean and how they're going to help me to fix this issue altogether.
But they gave us some recommendations, right?
Yeah, they're good recommendations, and I'm sure they're authorities on their subject, so they probably know what they're talking about. And the recommendation that they gave to try and fix this, well, apart from the general speculation initially, was that the standard method to prevent roller coaster issues is to positively validate load calculations. Yep. The only way to do this, of course, is using differential equations. For defense in depth, what we also want to do is add some load sensors to all the sparson joints. However, you want to be careful while adding these load sensors, as they can again affect the load calculations, which were the cause of the problem in the first half. And yeah, so this recommendation again has loads of stuff that I can probably do, but I have no idea how to solve the differential equations. I have no idea how to fix anything in my and make my system work. And oh, thank you.
So since that wasn't terribly useful.
It was completely useless. Yeah.
So since that wasn't very useful, we said, let's get a second opinion. Let's get somebody else to give us some recommendations.
So we got someone to come up with like a dummies report, like, you know, when you don't really understand something. And so I was like, yeah, you know, for a roller coaster to work, one of the things that you have to take care of is to ensure that the track is fully connected. This, well, when Captain Obvious came up with this solution, you know, it makes perfect sense, and it's actually accurate. And this is something that you would probably check. You check that the track is fully connected for the roller coaster to work. But it is completely useless in this context, and I have no idea how to use this to fix my damn system.
Right. So, what did you guys come up with as your hypothesis? What's wrong?
There's a runtime error.
A runtime error. Yes, that's in fact true. Yep.
It looks
Nice.
like it's a problem with life logic. I mean, just
Yeah, it's tough to come up with hypotheses, right? Yeah. So what is visible from a black box perspective? Now, I'm not here to like make fun of black box testing. It actually has its purpose. What can we see from a black box perspective?
inputs and outputs.
Inputs and outputs? Yeah, we sure can. I'm sorry, there was something over here.
Like I said, if it works or not.
Oh, well, if it works or not, it's absolutely true. Hmm? Yeah, that's right. We do need to know what the output. Well, that's why I showed you the video of so that was the output description. Yep. Hmm? That's right. Some expected outputs and outcomes. That's right. So, what are some security issues that are best figured out through black box analysis? Scenario-based tests? Yeah, sure. Okay. Fuzzing? Well, that's not an issue. That's a test technique. But yeah. What are those security issues? We're going to find some end-to-end issues. One of the great things about black box testing is we have the entire production environment available to us. So whatever systems are connected at runtime that we need in order to make this thing actually work. So if you're thinking, say, credit card, right? Credit card fraud checks are off to some third party off in the cloud somewhere. And you don't typically have that in the dev environment. You might not even have it in UAT because you had to pay them for that sort of thing. So sometimes you have to go to a place like production or a pre-prod environment before you get the full environment. So if you want to see the end-to-end system in action, then you kind of need this black box analysis in the real dev environment, in the real UAT or production environment. So now we're going to do white box analysis. We're going to open it up. Now this time you don't get the car. This is not runtime. So you can't execute the system, but you've got the source code. So guys, gather around the boxes. And you'll see various windows and openings. You can open them up. If it's taped shut, don't untape it.
The rest of you are missing out, sadly. We
Hey, don't
tried to
get-
get like a camera for you, but I don't
So
think-
maybe you guys can tell us what you're seeing too. They see track.
That's a good
That's
one.
good. Now, you're looking for problems, right? So you're looking for something that caused the car not to come back up.
Do you want some paper to write down? Yes.
Most importantly, you have to tell me what you're going to fix, because that's all you're going to be allowed to fix. Now, why would I do that? Why would I restrict them to only fixing what they tell me they're going to fix? Why would I do that? What's that? Because they wouldn't be the ones doing the fix. That is exactly right. So if you're providing security expertise to some project somewhere, and you're telling them what they need to fix, right? They're not the security experts. They don't trust themselves, and it's not even their job, really, right? So you come in with security expertise, and you say, fix X, Y, and Z. And so they say, right, got it, I'm going to go do X, I'm going to do Y, I'm going to do Z, job done. So they're going to tell me what they're going to fix, and that's what they will be allowed to fix. So, what are we going to fix? What's wrong? Well, let me promise you that you can fix it. So if rerouting the chain to the other side, while it's still wrapped in these boxes, is something you can do, then okay. Well, it did do at first. I mean, come on, we can do this. adjusted slightly. You did see it. Yeah.
Another theory doesn't have enough momentum to climb and disappear.
So what would you do to add momentum that you can in fact do right here, right
I
now?
can't really add momentum, but I can remove this line and then decide to make it less.
So you would adjust that curve. Okay. All right. Okay. That's going to be a tricky fix. Remember, what you tell me you can fix is what you're going to do. So if you're confident you can do that. This is like, I got to tell you, when you say I'm going to adjust the bank on that curve, that's like when someone comes to a software company and says, what you need is PKI. Right? Because you don't really get to do that. You don't get to come in and say, oh, let's just click install on the PKI. So over here, what do you guys think we're gonna do? What are you going to fix? They are going for PKI. All right. New data. What do we got?
We initially thought this little bit here.
Oh, okay. That could be it. So they found a little peg on the track, and they think the car might be bumping into that. So what would you do? Would you remove that? Because you can't do it. All right. Let's not do it yet. All right, so let's walk into a little bit of discussion. I'm going to let them sort of, like rabid dogs, sort of snarl over the dead carcass there. Of course, we have had white box testers look at our system before, and so we did, in fact, get a description. The roller coaster is not functional. Everybody's good at this. It seems to have the following problems: loose joint connections, extraneous joint on a rail. All these issues are extremely dangerous and need to be fixed before the roller coaster can be put back in service. A moving car coming in contact with any of these defects will create catastrophic consequences. Sounds like every pen test report I read, right? The next person that logs into this website will die! And it's never quite like that, right? I mean, look, we know that Target's website probably has trouble. Is that where the 40 million credit cards went? No, it isn't. So think of how many pen testers have delivered a pen test report to Target saying, if you don't fix this, you're going to lose 1 million credit cards. And that's not where they came from. So the recommendations that come along with that, though, say this: ensure tighter foundation joints, remove the extraneous joints on a rail, and they even give us a standard to follow when building our roller coaster joints. What do you think? I mean, if I gave that to you, could you do that? Assuming they point out which joint is extraneous. I mean, that's actually it's not so bad. I mean, you could go do that. Tighten stuff, take something off. So what's good about white box testing? What's different? What can we see here from a white box perspective? You can see how it works. You can see what's at the back end. Maybe. Back end still implies runtime. You can definitely see how it doesn't work. You can certainly see things that don't work. That's right. So what are some of the bugs that are best found through white box examination? Logic flaws? Absolutely. Logic flaws. Syntax error? Well, if it compiles, you presumably don't have syntax errors.
Arithmetic errors?
What is it?
Errors in the arithmetic.
Errors in the arithmetic, heck yeah. In fact, if any of you were watching the news, about a year ago now, I think, they had one of these online games that has like gold in the auction house, right? And you could bid negative gold. Now this is just fabulous, right? Because you can bid negative gold, and the more negative your number, so sort of the bigger negative number, minus 1 million, would beat minus 1,000. And the fabulous outcome of this was, if you won by bidding negative 1 million gold, you not only would get the item, but you would get the 1 million gold. So it's just completely fabulous. And you know that that's just a bug in the source code, right? Somebody just somewhere forgot to check if bid is less than 0. Right? They check to see if the bid is less than the gold that you have. Yes, it is. I bid negative 1 million, which is a lot less than the gold I have. Right. So guys, it's time to implement the fixes you told me you were going to implement. So now you're putting on your dev hats, right? So the security guys have gone. They left the report that said you should fix that curve, or whatever it is you want to do there. You guys said you wanted to pull that thing off the track.
Do you guys have like a, do you have a report for me? Like you just,
Yeah, it just says a kink in the trap, twist or remove. So it says.
Okay, take the truck and
kinky track issues.
Yeah.
Yeah, okay. This bit. Okay, I'll leave that here. Yeah, see if, do you think that fixes it? Yeah.
you guys just let us know when you think you're done with your repair. Now, if you break the system while you're repairing, that's going to get caught in the regression test. You're right here. Does anybody up there got an alternate theory as to what's going wrong? Something you think they didn't see? The car doesn't work? Oh, invalid input. Isn't that a fascinating one? He suggested maybe the car is actually broken and doesn't actually work. Turns out that's not the case, but it's a very, good thinking outside the box kind of idea. All right, are we ready for the car?
Yeah, so we have a fix here. They've removed a joint.
They've implemented the fix.
Yep. Fix candidate. You test in production.
We're going to put the car back on the track. Wrong type of leaves on the track. That is probably it.
Is that Scott Rail or are you talking about?
Yeah, I was wondering about the wrong type of leaves on the track because, some new trees sneak up on them. Trees that have never been around that part of the track before. Alright, so we're going to hold off until these guys are done with their implementation. Alright, now.
Yeah, so you push
guys
it
ready for your car yet?
and you wait the eventual.
Uh-oh.
You just move it as they come to try and send
Yeah, I think they've, I think they outsourced this to the wrong vendor. You guys didn't think of anything suspicious with a random piece of taped on thing? Okay, just one. Doesn't actually do anything. That's
I thought it was that to get the clearance of the car.
yeah, and then the car runs on the other side of the track anyway. That's a red herring. It's what we call dead code, right? We got the pieces of the roller coaster just laying there. That's dead code. Hi. Do you guys think you're about ready?
Right, you know what? Okay. Yeah, you can fix the thing that you think is.
Now.
Put the other thing back.
There we go. Okay, so these teams seem to be fairly. Think everybody's ready?
Yes.
All right, so go ahead, you guys. Go ahead and hit your button and see what happens.
Deploy and pray as a.
That's right. And goes. Oh! Okay, so they broke the rules and they succeeded. Let's see what these guys did. Yeah, they found the bug. Okay, so since you guys fixed it, what did you actually find when you got in there? Oh, this is great. They don't even know how to fix it. They fixed something and it worked. They deployed it. Somehow that got past the change control committee. They did something in the commit log. All right, so what do we got? There was a support touching the rail. So as the car came by, there was no clearance for the car to hit the rail. That's right. So they figured it out. Now they broke the rules because I told them they could only fix what they told me they were going to fix. Right, and then they went and fixed something that they found while they were in there, which is all right. Enterprising developers, that's a good thing. So you guys figured out? You figured out which support it was?
I think so.
Yeah, there it goes. Woo! All right, good job. All right, why don't you guys take your seats? We're actually in the home stretch here.
Thanks, guys.
Very good. Thanks to our two debugging teams. We'll all go on to have illustrious careers in software testing. So what have we learned? For one thing, we want to minimize security jargon. And this is a really important lesson. Standing here as a security guy, talking to a bunch of security people about security, it's really easy to get sucked into the echo chamber and forget that a lot of people have no earthly idea what DOM-based cross-site scripting is, right? But the guy that you're talking to is not an idiot. That guy might be able to do real-time transactions on an MQ series system with guaranteed delivery in the order or guaranteed exception handling if it fails, right? The guy who's developing the code is not an idiot. he just might not know what DOM-based cross-site scripting is. So the doorstop and the gram toll and whatever the heck that stuff is, that's cross-site scripting to that guy. So we have to look out for security jargon. We have to give guidance in the language that the reader will understand, right? And very often, this is the far side from 100 years ago. This is what dogs hear. You know, we say, Ginger, I've had it with you. Stay out of the garbage. You understand that, Ginger? Get out of the garbage or else. And the dog hears blah, blah, Ginger, blah, 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 Ginger, blah. All right? And so, you know, developers, when we talk to them, sometimes that's exactly what we sound like. Blah, 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 pwned, blah, 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 root shell, blah, 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 cross-site scripting, blah, 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 disaster. Right? And if we're not talking to them in the language that they speak, then we're going to talk right past them. Anybody, what language do developers speak? No, they do not speak binary.
English.
What? Fear? No, they don't speak fear. No, they don't speak English. What developer speaks English? Code. Developers speak code. That's all they do day in and day out. Java, .NET, PHP, Python, Ruby on Rails, Scala. You know, the number of languages that developers are writing in is vast and horrendous. And none of them is the security language that we speak all day long. So if we come to them with a bunch of security terminology, they're not going to get it. We have to show them code. Right. So applying the lessons that we've learned, huh?
Right, so with black box testing, it's actually one of the best ways to start off with security testing in general, because if you've tested one web application and if you're trying to test another web application that was written in this obscure Haskell framework, and the only people who can write code for it is some person and his dog, even then you know where to start and what to, the general kind of things that you look for. And it's actually quite effective in discovering stuff that is easy to find, and you can often find very high impact issues. And as Paco said earlier, it does provide you the end-to-end coverage. You see an application in its natural habitat, if you will. You know, it's connected to your database, it's connected to all the other systems that it relies on. And you get that kind of perspective where you know what the system is supposed to do and how you can try and break it. But you don't actually know how it works, how it does all of those things, but you can see it in production and try and test all the features that it exposes.
Yep.
But what's not so great about black box testing is that you don't have enough context to try and find architectural flaws and bugs that maybe actually might be of higher value to the business themselves in terms of like logic errors and stuff like that. It's not very easy to find these kinds of issues through black box testing. And there's always that temptation to try and speculate. When you see a cross-site scripting in, say, a production web application, you think, well, you should probably do some, output encoding. But the thing is, it's very hard for you to be sure that it's the application that's causing the cross-site scripting issues. You might have a bunch of reverse proxies in front, you might have another third-party application in front. So it's very hard to come up with the actual source of a vulnerability that you found in production using black box testing.
So from a white box perspective, right, I mean, the good thing about white box testing is this is definitely broken, and this is how you fix it, right? That's a really important and powerful thing. I'm not speculating when I have the source code in front of me. I know what is in fact broken, and that's a good thing. And so we can actually get into all kinds of different code, we can find all the bugs and so on, but we don't see the end-to-end situation very easily. So one of the biggest problems I've run into is I get these systems and I look at the source code and I say, we're going to generate this error message here with user output, user input. Where does that go? And the developer says, I don't know, I'm not really sure. Right? Because we don't know if that goes off to the network operations center, we don't know if that goes to a log file, we don't know if that ever comes back to an end user in some way. When you're looking at the source code, you often don't see the whole end-to-end connectivity. And you need that big picture to actually drive the vulnerabilities home. So I think we can put it together pretty simply by just saying, here's the difference, right? Black box testing, boop, there it is. I've got some inputs, I got some outputs, I can show them to you. That's a problem. But where's the problem? Like, what lines of code does the developer have to change to make that go away? And the answer is, I'm not really sure. And if you ever tell a developer that a regular expression is the answer to his troubles, you are wrong. It isn't. I mean, because everything that you might ever want to do with input validation and session management and all that, there's a library for that somewhere, and there's a right way to use that library. But Blackbox, it becomes really hard to give them just what they need. On the other side here, we've got, you know what, there's request.get parameter. I know exactly what that does. It pulls out some stuff off the request from the web browser. Oh look, here's a SQL query that's being pulled together, and I see where you take the stuff from the end user, you slap it into a SQL query and send it off to the database. We can fix this right here and know that this problem anyways goes away. And if I come back and I tell the guy prepared statements, I've spoken to him in the language of code. He can go look up that class. He can look up the references. He can figure out how to do that. Very, very handy. And so really, you know, that's the black box, white box thing. Questions, comments, or discussion? Ooh, which testing do I find most common? So, that's a good way. Which do I find more common, white box or black box testing? It depends on who you're talking to. So, security people, we do an awful lot of black box testing, right? The rest of the world, the rest of the development team, the functional testers, the integration testers, regression testers, they're all doing white box testing. They all have the phone number of the lead developer, and they can all call him up and say, hey, how is this really supposed to work this way? So I think we in security do a lot more black box testing, and everybody else is doing white box, and the rest of the development team, the developers, the testers, and so on. I'd love to see us move from black box testing results and hand those off to the regular functional testers. And say, you know what, guy? I'm giving you all the steps you need to reproduce this. You have to now run this test every time you make a release. Every release, you're going to run the same case that we found cross-site scripting. And that way, the security guys can never find that bug again. Right, so has anybody not put their name in the box? That's not the box. Yes, everyone has not put their name in this box. The other box is over here. Any more names to collect? Anybody want to take a crack at putting your name in last in case that becomes like the most time? All right, we're good. Oh, I'm sorry. Go ahead. Fire away. Which is more varied of the two? I think there's equal variety in both, right? So you can have fuzz testing. And fuzz testing can be mutational, it can be generational. You have white box testing, which is like all the static code analyzers, as well as the compilers and syntax checkers, as well as just good old peer review, the four eyes are better than two problem. I don't know that there's more variety or less variety. And our first attempt at a winner. Drop table users. No, it looks like someone whose handwriting I can read. Samantha Beaumont, would you like to come pick up a roller coaster? She met all the eligibility requirements. She had a piece of paper with her name on it and handwriting I could read.
Has a smiley as well.
And a smiley. That was the input that really messed me up. I thought that was part of the query. And someone else who has worked on his handwriting, Daniel Charlton. There you are. We got the after party. Yeah, that was your problem. We got the after party later. I'll be doing cigarette sometime later on tonight.
I'll give you the manual for it.
Anybody fancies a cigar? You let me know.
If you're some sort of like a masochist.
And that's it.